Okay, so for these we need to find the discriminant. The discriminant is used with using the quadratic formula. It's this, what's under the radical, the b squared minus 4ac. So just like we did with quadratic formula, identify the a, b, and the c. So b is -2, so it's going to be -2 squared minus 4 times a, which is 1, times c, which is -3. Okay, simplify this, so that's going to be 4 minus a -12, which is 4 plus 12, which is 16. So what that is saying, because my discriminant is a positive 16, I know my solutions here are going to be two real solutions. And if you notice, your parabola, your graph, is intersecting at positive 3 and -1, which that is giving us our two solutions. Positive 3 and -1, and showing us our two distinct x-intercepts. For here, same thing, b squared minus 4ac, again used from the quadratic formula, so I do opposite b, I do b squared, b is -6, -6 squared minus 4 times 1 times 9, so I get 36 minus 36, which is 0. Whenever you have a discriminant of 0, it's always one real solution. Really, it's that one solution repeated. If you solve this by factoring, you would get x minus 3 squared equals 0. When we square root, we would have x minus 3 equals plus or minus 0. So we'd get x equals 3 plus 0 and x equals 3 minus 0. So basically it's two solutions, but it's just the same number repeated. So when you get a discriminant of 0, it's a repeated solution. In this case, the repeated solution is at positive 3, and you should see that in your graph because your graph bounces off the x-axis at 3. And a bounce on your graph on the x-axis shows its repeated solution, which we will get into here in the future. And then lastly, again, using the discriminant, it's b squared minus 4 times a times c. So 3 squared is 9. 9 minus 12, 4 times 1 times 3 is 12, 9 minus 12 is -3. Whenever you have a negative discriminant, or in this case a negative underneath the radical, because your discriminant is what's under the radical, your solutions are going to be imaginary. So that means they have to have an I in them, which obviously if you're trying to take the square root of a negative, it's always going to have an I in it. And you should see from the graph here that for these, and again the graph in your notes, that imaginary solutions will never cross your x-axis if you had to solve it by graphing.